Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Welcome to Module 1, Basic Device Configuration. The goals for this chapter are to be able to do an initial setting for a switch, setting up switch port access, remote access, setting up a basic router, and verifying directly connected networks. So first section is 1.1, configuring a switch with the initial settings. So before we talk about how to configure a switch, we have to talk about how the switch powers on. Switch power on is a 5-step process. First step is post, which is a power on self-test. It tests the CPU, the RAM, and the portion of flash that holds the file system. Step 2, it will load the bootloader software, which the bootloader is a small program stored in ROM that is ran right after post. Step 3, the bootloader will perform a low-level CPU initialization, basically turning on things like the registers. It will control whether physical memory is mapped and how much memory is actually allocated. And it will verify quantity and speed of memory. Step 4, the bootloader will initialize the flash file system that is located on the main board of the device. Step 5, the bootloader will locate and then load the default iOS operating system into memory. Keep in mind, a device can have more than one iOS. The default will be whichever one is set. Next, we can talk about the boot system command. The boot system command will actually let you set what iOS to load. It actually has 4 main parts. Boot system, which was the main portion of the command. Flash will be the storage of the device. It doesn't always have to be flash, but in this example it is. We will then give it the path to the file system. Here we're giving it a folder, and then underneath that folder or directory, it will be the iOS device. Keep in mind that iOS file is not a .iso. It's not a .ios. It's not a .exe. It specifically is a .bin file. The iOS files are actually stored as bin files. Boot system can actually come from an array of storage. Doesn't necessarily have to be flash, but in most basic configurations, it is coming from flash. Next, we have to talk about, if we're looking at a switch, how does the switch look? Typically, if we're looking at a Cisco 2960, we'll have this diagram on the left-hand side will be on the switch, system, RPS, stat, duplex, speed, and PoE. SYST is short for system. Basically, is the switch powered on and receiving proper functionality? If yes, the LED will be on. Next, RPS is redundant power supply. This will show the RPS status. Next will be the status. That will be the port status LED. They should be green, and essentially when a port is active, it will light up green. Next is duplex. When it's green, it will indicate the port duplex mode is selected. Again, it will either be half duplex or full duplex, and then the lights may differ based off the duplex. Realistically, full duplex is the default, and that's what it should be at. Next will be speed, or port speed LED. When the LED is green, it will indicate the port speed mode is selected. On the actual switch itself, the ports will either be green or orange. Green should be speed of 100 megabits. Light of orange should be, it will be a gigabit connection. Next will be PoE, and this will represent if PoE is set on those ports. PoE is not enabled by default. PoE is not set up by default. You need to make sure that if you're using PoE that it's turned on the ports that are needing it. Again, to change between the stat, duplex, speed, and PoE, you would hit the mode button on the bottom left-hand side of the switch. In this example, it's right here. That would be the mode button. And it will cycle between status, duplex, speed, and PoE. You'll have one of them selected at a time. Next, we can talk about the lights. What do they mean? So, if we're talking RPS, if it's off, there's no light, there's no RPS. If it is green, RPS is present and is ready. If it's blinking green, RPS is up but not available. If it's amber, it's in a standby mode. If it's a blinking amber, an internal PS power supply has failed and the RPS is providing power. If it's alternating between green and amber, means nothing. Realistically, you can go through the chart. I don't need to go through each section. Some switches on the speed, when it is gigabits, will be orange. I know in the previous slide I said orange. Some will actually blink green. It all depends on the type of switch that you have. I did generalize it being orange, but on most Cisco 2960s, it will be blinking green. If it's PoE, again, you can go through the options there. Next, what happens if we have a switch and the system file system on it crashes? What do we do? How do we recover? So the recovery is a 5-step process. We're assuming you have physically have the device and you have a console cable. You will connect the PC to the device using the console cable, plugging into this. Here we're using a switch as an example. You'll be plugging the PC into the console port of the switch. You'll configure the appropriate terminal emulator and connect to the switch. Once you connect to the switch, you will then unplug the switch power cord. You will then plug it back in. That will be step 3, reconnect power. And within 15 seconds, press and hold down the mode button while the system LED is still flashing green. This will let you get into a recovery mode. Again, when you plug the switch in, you have within 15 seconds to press and hold the mode button. Step 4, continue pressing the mode button until the system LED turns briefly amber and then turns solid green. That will let you know to actually release the mode button. Step 5, the bootloader switch prompt will appear in the terminal emulating software on the computer. The bootloader command line support commands to format the flash file system. It will also let you reinstall the operating system. It will also let you recover a lost or forgotten password, for example. You have to know some basic Linux commands, Unix commands. You can navigate the CLI using things like dir. That will let you be able to see the different directories. Again, this can also be used for password resets if necessary on a switch, but you have to do it in a correct order. The big thing to recognize is when you power it back on, 15 seconds, within that first 15 seconds, you have to get in and hold the mode button to properly tell the switch to boot in the right prompts. Alright, moving on. How do we configure switch management? Again, we're going to be setting a console cable to a switch. You have to be able to set an address to a switch. That will be using a SVI, or Switch Virtual Interface, and those will be tied to individual VLANs. VLANs we'll talk about a little bit later, but essentially you have to give the switch an IP address to be able to remotely manage the device. So by default, the switch is configured to have its management controller through VLAN 1. That means all the ports are attached to VLAN 1 by default. You can modify this and change the default LAN if necessary. you can set a management LAN if you'd like. So to configure the management interface from a VLAN, you would go and you would type VLAN interface. You'd have to go to its configuration mode. So interface VLAN space 1, enter. That would let you apply an appropriate IP address. I have a switch, just basic switch, no configuration. I'm going to get into its configuration mode, and I want to apply an IP address. So I would do interface VLAN 1. Notice that will put me at a interface subcommand, IP address, and apply an appropriate address that's tied to your network. Make sure to turn it on. And that's it. You've just now configured a SVI on a switch. If you want to modify the management VLAN to say VLAN 99, you can actually set an interface for VLAN 99, but it will not actually show up and working or functioning until you actually create VLAN 99. Switches may need to also be configured for an IPv6 address. Not all Cisco switches are capable of doing IPv6. Older switches may not be. So to configure an IPv6 address on a Cisco 2960 running iOS version 15 or above, you'll need to actually enter the global command SDM preferred dual IPv4 and IPv6 default, and then reload the switch. This will let you do both IPv4 and IPv6. Realistically, we have a lab later that will outline how to do this for our switch configuration. Moving on, we can talk about how to set up addresses. Again, I did it via a terminal in Packet Tracer, but these are the commands. You'd go to the terminal, go to the appropriate interface, give it an appropriate address, set up the IPv6 address if necessary, turn it on, and then save it and reload it. So next we have to set a default gateway. For a default gateway, assuming only one VLAN, we would be, again, go to the terminal. Once we're at our terminal, do IP default gateway and give it the appropriate address. Again, this should be your layer 3 device on your LAN. Typically, it will be a router. It'll be the router's LAN interface. And again, if you're not sure about this, I have previous videos that talked about the importance and functionality of a default gateway and how to determine what they are. Step 3 is verify the configuration and verify the interfaces. So you will do a show IP interface brief, and that will see if the interfaces are turned on. So again, I have my packet tracer, I log in, exit, I will do a show IP int brief, and it will show the VLAN and if it's up or down. In the lecture, they modified VLAN, they moved to VLAN 99. In my packet tracer, I did not. Again, we have labs that will explain that. Remember that just because the switch has an IP address, that doesn't mean the switch will route IP packets. A switch typically is layer 2, and all routing will be performed by a layer 3 device. So the switch, while it has an IP address, still needs to send all IP packets outside the network, destined outside the network, to the layer 3 device, or typically the router. Yes, there could be a layer 3 switch, but most cases it will go to a router. So again, basic switch should be able to cable up the switch, be able to provide basic functionality for the device, verify and test network connectivity, manage the MAC address table, And we will actually have a lab that walks us through those 4 parts. Moving on, we have a configure switch port access. This is going to be setting up more of the port functionality. Like duplex. By default, full duplex allows communication simultaneously to be sent and received. This is bidirectional. You can actually set half duplex so you can either be sending or receiving. This is unidirectional, and realistically this is not done. It should be left at full duplex, and that allows for full functionality. Moving on is speed. You can actually set the port speed. By default, port speed is set to auto. So if you have a 10100 device plugged into a port, the port will negotiate the highest speed. You can manually set it to a speed. However, if you manually set it and you plug in a device that is not currently that speed, that port will not turn on. Realistically, modern day networks, most things are gigabits. Leaving an auto is not a terrible issue, and you see it more common than not. It's important to note if we're talking fiber, fiber has to be manually set and will operate only at one preset speed and always full duplex. Alright, with that, let's move on to configuring a switch port. If you want to configure the speed manually, you would log into the device, go to the appropriate interface, set up duplex mode, half or full. Then you could set speed. The speed would be in megabits what you'd want. End it, save it, restart it, and the device will now operate at that speed. Again, realistically, leaving it auto is typically done. Auto-MDIX, this is always a fun one. Not all devices support or have Auto-MDIX. I will keep saying MDXI. It's a bad habit. I apologize. In previous videos I talked about this, but basically what the Auto-MDIX does is it will recognize what type of cable is needed and will apply it. What I mean by that is when you hook up 2 switches, in order for 2 switches to communicate, they should have a crossover cable between them. However, if Auto-MDIX is turned on and functioning, if you accidentally use a straight through cable, then the switch will then auto flip the ports internally so a straight cable will work. You cannot assume that all devices have Auto-MDIX. So again, when wiring up a device, always make sure to use the appropriate cable. Like devices, switch to switch, use a crossover. Router to router, use a crossover. Any uncommon devices, PC to switch, use a straight through. Understanding cabling types is very important. Alright, moving on. Verifying commands. Things like show run, show start, show flash, version, history, show IP interface. You can actually look at detailed information on an interface. Show IP interface brief will give you a brief view of it. Knowing how to navigate show commands is pretty important, and we'll actually talk more later in the training series about using show commands more effectively in troubleshooting. Next, let's talk about verifying switch port configuration. If we do a show run, we can actually look at the running configuration of the device. Here we're looking at a show run tailoring to the VLAN interface and the IP default gateway address. Basically, we're just verifying this piece of information. If we do a show interface and we actually list out an interface, you will actually see a detailed breakdown of the interface. Is it up? Is the line protocol turned on? What MAC address it has? What the MTU is? What the bandwidth is? What the delay is? The reliability, the sending load, and the receiving load. Those are big ones. If it's full duplex, half duplex, is it set to operate at gigabit or whatnot? The big things here actually, bandwidth, reliability is a big one, and the sending and receiving loads, those are important. Realistically, as we get into troubleshooting and we start looking at network congestedness, this is where we're looking at to see if a port is able to handle what is being sent and received. We actually look more at that in a later video, but I wanted to point that out just to show. The output from the show interface command, again, we're looking at media issues. If it is turned on, you should see the interface is turned up and the line protocol is turned up. If it is turned off, you should see that it is in a shutdown state. One thing that I do like to point out is if the interface is up but the line protocol is down, it's typically a encapsulation mismatch. So if you're setting up encapsulation, again, we talk about that in a later video, it may actually be mismatched. Again, whatever we do on one side of a wire, we want to do it the same on the other side to make sure that our protocols are set up on both. Again, if it is in a administratively down state, it's because we issued a shutdown command. So let's look at the show interface a little bit more in depth. We can actually look at things like runts and giants and errors and CRC issues and things of that nature. You can also look at collisions and output errors and late collisions. What do those mean? Realistically, as you move through the Cisco curriculum, the higher level courses, understanding the show output or the show command output becomes important. Understanding things like runts and giants help you to troubleshoot what's going on. Those error types are, if we're looking at an input error, that will be the total number of errors, including all runts, giants, buffers, everything. If we're looking at just a runt, that will be a packet that are discarded because they are smaller than the minimum packet size. The minimum packet size is typically 64 bytes. That's a runt. If we're looking at a giant is anything above 15, 18 bytes. Yes, I understand that we can have jumbo frames that will be above 1,518 bytes, but that's outside the normal content for what we're covering. We have a CRC error. Those will be how many CRC errors are generated when the calculated checksums are not the same as what's received. Output errors are the sum of all errors that prevent the final transmission of a datagram, whether it be a frame, typically a frame because we're dealing with switches, that is being examined. Collisions are the number of messages retransmitted because of a collision, and a late collision is a collision that occurs after the first 512 bits of a frame. Realistically, this is good stuff to know, and if you're troubleshooting, these are good things to know for layer 1 and layer 2, but these are things that you normally will not memorize. You need to be able to look them up where they're at. Moving on, we have our runt frames, which we've already talked. If they're smaller than the 64 minimum allowed, giants are larger, unless jumbo frames are enabled. CRC errors are one of the big ones because we'll actually do a CRC checksum to verify if a frame is accurate. Collisions and late collisions we've already talked about. Again, late collisions after the first 512 bits are sent. If we are looking at how to troubleshoot layer 2, the network access layer. Can you see the interface? Is the interface up or down? If the interface is up, then is there an issue with the layer 1 media? Issue with the duplex? Issue with the speed? If the interface is not up, we check the cable, we check the connectors, we check the speed on both sides of the cable. And then if we are looking at if that fixed the issue, if yes, great. If no, then we escalate the issue. One thing that I don't see here at all is the interface up? Did we verify that we turned on the interface? I always find that people will configure devices and forget to turn on the interface. So, is the interface up? Was the no shutdown command issued? Then follow the flowchart. That would make the most sense. Alright, moving on, let's talk about how to secure remote access for a device. If we are looking at Wireshark and we're capturing data on the wire, and you try to telnet into a device, you will capture the username and password, plain text. That's because telnet operates on port 23 and everything is sent in clear text. If we're using SSH will use port 22, and it provides a secure management connection to the device. Secure meaning it will encrypt the data. Meaning if we're looking at Wireshark and we're actually looking at the connection, Wireshark should show it as a secured connection. What's really funny is when you're looking at this, what's being up on the window is actually the telnet window, not the SSH window, because again the password would be encrypted. So how do we make sure that our switch is able to handle certain commands? Well, first we have to make sure what version of iOS we're running. So if you're on a switch and you do show version, you can actually see what version of software we're running. Here we're running the C2660 LAN-based K9 -M license, version number 1502-SE7. There is actually a video that I've previously done that will break down the licensing that will explain this better. The important part here is with the with the show version, it will actually show that it supports cryptography by the K9. The K9 after LAN base shows that it supports basic cryptography and encryption features. So how do you configure SSH? Again, we have a lab that will do this, but we have 6 general steps on configuring SSH. So the first step is you have to verify the switch actually is able to handle SSH. What you can do is look at the version, look at the cryptography settings to see if you can. Or a lazy way of doing it is you can actually do a show IPSSH command. The SSH command, if the device does not have the license for it, it will say it's an unrecognized command. If the device has the licensing for it, it will actually display a different error, but the command will be recognized. Step 2, configure the appropriate IP domain. That means configure the domain name of the network that will be using the IP domain name and the domain name global configuration mode within the global configuration mode. Step 3, we have to generate keys. Now again, the keys will be an RSA pair key, and we'll be generating an RSA key automatically when you enable SSH. You can use crypto key generate commands to generate a new key. You can always delete old keys if you view that they have been compromised. Step 4, you have to configure user authentication. The SSH server can authenticate users locally, or to a remote server like a Radius or a TACAX server. Realistically, basic level, we're probably going to be doing a local user. And again, we create a user by doing a user, username, space, the actual name of the user, space, secret, and then giving it a password. Step 5, we need to configure the appropriate interfaces to accept SSH. So if we're looking at the VTY line, you have to enable SSH protocol on the VTY lines using the transport input SSH. Step 6, verify what version of SSH you're using. Enable SSH version 2, that should be done by default. The devices will handle both 1 and 2, but 1 has some vulnerabilities, so you don't want to do that. So you actually want to make sure you're using the newest version of SSH. And that is enabling SSH in a nutshell. Again, a lot of steps. We have a lab that will walk us through how to do this on a switch. How do we verify SSH is turned on? On a client machine, use a terminal emulator like PuTTY, and you'll do SSH. You'll SSH to the IP address of the device. When you actually do SSH, IP address of the device, hit enter, it should prompt you for a login. If it does prompt you for a login, you know the device is accepting SSH commands. Again, we have a lab that will let us check this. On the device, we can also do a show IP SSH, and that will actually show us the connections. Show IP SSH will show SSH version. Show SSH will actually show the connections. Again, here's the lab that we'll be doing. We'll be setting up a secure password, encrypting communication, and then verifying SSH. Moving on, we have our basic router configuration. Basically, same thing as a switch. You'd be setting up a host name, enabling a secret password, setting up the appropriate line interfaces, a line console 0 and the line VTY. Again, both routers, switches, same thing. We'll also be setting up secured passwords so that no password is left in plain text. That's what the service password encrypt does. And again, common initial configuration for both switches and routers. You also have to set up a banner, and you have to save it. I'm moving through this fairly quickly because I'm assuming you know how to do a basic device configuration. I've done other videos where I walk you through basic device configuration, so I don't want to spend that much time. Next, we have to talk about dual stacking topologies, meaning we have multiple logical addressing schemes, meaning we have both IPv4 and IPv6. That makes this a little bit more complicated, but it is totally doable now that we live in a dual IP world, meaning we have both IPv4 and IPv6. Globally, IPv6 is kind of taking over, but certain countries IPv4 is still really prevalent and IPv6 is still more of an infant. It's important to understand that for routing you should need at least one IP address by default. So either IPv4 or IPv6, but at least have one. Because within the Cisco realm, we're going to be looking at configuring mainly IPv4, but we're slowly going to be introducing more IPv6 configurations on all the devices. You have to turn on the interfaces. You have to have them activated, meaning you have to do the no shutdown command on the interfaces to turn them on. Optionally, you can also set a description on each interface so that you know kind of what they are. For example, here we have a configuration for gigabit 0, 0, 0, 0, 0, 1, and a serial interface. So we actually will navigate to interface gigabit 000, give it an IP, give it a IPv6 address, give it a description, turn it on, and then we repeat for the other three interfaces. Again, we have to have at least one IP address assigned to it, and that's typically an IPv4 address. We also have what's called a loopback address. And a loopback interface is a logical interface that is internal to the device and is not assigned to a physical port. And it's considered a software interface and is automatically in a on or up state. The loopback interface is very useful when we're talking about testing and managing iOS devices because it ensures that at least one interface will always be available for connectivity. Like if we're looking at pinging something, this type of interface will always be up. You can enable and assign a loopback address by typing interface loopback, give it a number because you can have multiple loopbacks, and then apply a IP address like you normally would. We have a lab outlining how to configure the router, both for IPv4 and for IPv6. Last section is 1.5, verifying directly connected networks. Again, with this material, we are looking at directly connected networks and static networks. We're not talking routing protocols too in-depth in this course. So how do we verify? We have three main show commands: show IP interface brief, show run, and show IP route. Again, the show IP interface brief, we have both IPv4 and IPv6. Same thing with show route, with IPv4 and IPv6. When we do a show IP route, we have two types of items that will be connected. If we're talking directly connected, we have C, which is connected, and we have L, which is local. With the previous version, iOS, we only had a connected. They are slightly different, but they essentially mean the same thing for this course. Here we have a show IP interface brief. You'll notice it will list the interface and just a brief information about it. The interface name, address, is it up, is the protocol up. If we do a show IPv6 interface brief, again, it's going to show interface, its address, and its mode. Is it up status and is it up protocol? If the status is up but the protocol is down, typically it's an encapsulation issue. If the status is down or administratively down, it's because the no shutdown command wasn't issued. If we are looking at verifying individual links, we can actually navigate to the individual interfaces. So instead of doing a show IP interface brief, we would do a show IP interface and the name of the interface. Here we're looking at the IPv6 version of the interface, so show IPv6 interface gigabit 000. That will show that IPv6 is enabled. It will show the link local address. It will show if there is a global unicast address and the appropriate groups that it may have joined. Again, FE80 is a link local address, like a private address. A global unicast address is more like a public address. Normally, link local address interfaces are automatic. A global unicast address is not automatic. We also have the ability just to do the basic show run, and that will show the running configuration. And again, that will be more general information because it will list the entire config. So it won't just be the IPv6 information, it will be both the IPv4 and the description. It will also show the duplex speed and actual speed that it will run at and more. And again, you can always do show interfaces. You can do a show IP interface, and you can do a brief or you can be specific. Another one is show IP route and show IPv6 route. Here we'll have our directly connected and our locally connected routes. This routing table will show paths between devices. The local host route has an administrative distance typically of 0 and has a /30 mask for a IPv4 or a mask 128 for IPv6. The local host route is for routes on the router that owns the IP address. Basically, it is used to allow the router to process packets destined to that IP. In a later video, we will actually talk about a color code breakdown of this, that we can actually understand the specific steps in each syntax used for the routing table. Moving forward, we also have a filter command. So you can do a show command, and you can also then manipulate it with a pipe. You can provide certain selection areas. You can include or exclude or begin in certain areas. Realistically, this is kind of outside the scope of a normal associate, but you can. All of this is going to be done through filtering expressions if you wish to. And I believe we have a lab that outlines how to do some of the filtering. We have a command history. If you ever programmed a Cisco device, you can modify it by looking at the show history, or if you're connecting using a terminal, the terminal should also have a history. You can also hit the up arrow or down arrow to look at commands that you've recently issued. And those are all part of the history feature set. Lastly, we have our third and final packet tracer that will help us verify both IPv4 and IPv6 network connectivity and troubleshoot connectivity, and I believe looking at the route table. Last module is our practice and our quiz. There might be an additional packet tracer or two after this, but this is the summary table. If you have any questions or concerns on this material, please reach out and I will get those answered. Thank you.